Okay, so today in this lecture we are going to continue with our series of lectures that we are doing on coupled oscillators, and today we are going to do the case of the unequal masses and springs. Okay, let us start with the problem of unequal masses with spring. So this is how it was. Just give me. So here it was. So we now have in the previous lecture we had only two equal masses. In this we are going to have two unequal masses. So let us take for simplicity two unequal masses as one being double of another. And in this you have a rigid ball here, and here you have mass m, and again you have a spring, and again you have this mass 2m written over here, and then again you have a spring, and this is it. Okay. Now what will happen? Uh, So if I displace my masses from equilibrium in a manner that one of the displacement is greater than another, then what will happen? There will be some oscillations which will start getting executed, and there can be two independent modes of oscillation which will be executing oscillations with some pure frequencies. Those two modes are called as normal modes that we've discussed in the previous lecture, and these normal modes we are going to discuss here. So let us say that this mass has moved through x1 and this mass has moved through x2 with the condition that x2 is greater than x1. Then what will happen? What will happen that your mass m will be will be there will be force here. Okay, x1, this is the restoring force, because here this is at station, this is stationary, and here what will happen? This particular spring will elongate by x2 minus x1. So this will there will be force here kx2 minus x1. This is your mass, first mass, that is the left mass, and the right mass will feel a force here in the restoring direction kx2, and another restoring force kx2 minus x1. So the differential equations corresponding to both of these would be minus kx1 and then again plus, so you will get minus 2, and then you can write kx2, and then m2m x2 double dot will be equals to minus it will be equals to minus k minus, I'll write 2kx2 and uh, minus kx1. So this is how the equation would be, right? And if I try to solve this write this in the proper differential equation format, I'll get plus 2 omega square x1 and minus omega square x2, minus omega square x2. Okay. So this will be and then sorry, so this will be like this will be equal to 0, and then another one will be x2 double dot 2x2 double dot, sorry, and then plus 2 omega square x2, and then you will have plus uh, omega square x1 equal to 0. So this is your equation number 1, this is your equation number 2. And in the previous lecture we've discussed that solution for this differential equation can be assumed as some trial function. So let us take the trial function as uh, let us take that as a1 or a1 e to the power iota alpha t, and take x2 as a2 e to the power iota alpha t. Okay, and if I take these two solutions, and if I replace these solutions in these two differential equation, I will obtain uh, minus alpha square uh, plus 2 omega square, and then I will obtain minus omega square here, and I will obtain again some omega square here. I feel okay, there is a negative problem somewhere. Minus minus, it will be plus here, because see both of them are acting in this direction. So this will be, I think here it will be a minus sign also. Okay, so this will be minus omega square, and here you will have again there's a problem here. I think this is 2, this is 2 omega square. Where is that alpha square then? Okay, so let us solve it and see. So if I replace this x1 and x2, what I'll get minus alpha square, okay, minus alpha square a1. So keep in mind a1 also, and here you will get plus 2 omega square, and I'll write it as a1 e की power iota alpha t minus omega square a2 e की power iota alpha t is equal to 0. And this equation, the second one will be, again, if I write minus 2 alpha square and plus 2 omega square, and but remember this is a2 e की power iota alpha t, because see x2 is a2 e की power iota alpha t, and this will be minus omega square a1 e की power iota alpha t. So I'll write minus omega square here, and I'll write minus 2 alpha square plus 2 omega square, and then you have this uh, a1, and you have this a2, and here you get 0. Okay, now as you can see that if this is the differential equation, and this is the system of equation. In order to obtain a non-trivial solution, in order to obtain non-trivial solution, this determinant, the determinant minus alpha square plus 2 omega square minus omega square, and then you have this again minus omega square here, and minus 2 alpha square, and then you have 2 omega square. This should be equal to 0. And if this happens to be 0, what does it mean? It means that uh, like minus alpha square plus 2 omega square, and then again I have minus 2 alpha square, and then 2 omega square minus minus plus, and again a minus, omega की power 4 should be equal to 0, and that would yield me a solution 2 alpha raised to power 4, and then I will have minus 6 alpha square omega square and plus 3 omega raised to power 4 equal to 0. This is my equation number 3. Okay, now I want to find what will be alpha in order to obtain the displacements x1 and x2 as a function of time. Since I've assumed them as a function of time, here you can see if I know alpha, I know what are the displacements of the masses m and 2m as a function of time. So this is something that I need to find. So if I've solved this differential equations, you can see as not differential equation. If I solve this quadratic equation, you can see that this particular thing is a quadratic in alpha square. So this is a quadratic in alpha square. So you can solve this. So alpha square will be 6 omega square plus minus root over, again you can write uh, 36 omega की power 4 and minus 24, and you have this again omega की power 4 divided by 4, right? Divided by 4, because see 2 is here. So what you'll get alpha square is equals to this will be like 3 plus minus, and then you have root over 24. 24 is 4 into 4 into 6, or you can write if I want to write 3 into 8, that will also do. So let me write it as 24 only right now, and then I'll see how to make it easy. So this is how it is. Okay, and yeah, right, 6 here. Okay, so now what would be your alpha? What will be your alpha square in easier terms? You can write this as 3 plus minus, and this 24. If you take 2 common out, so this will remain as I think 3 only here, and here it will be 2. Because see, you take 2, this 24 can be written as 4 into 6, and if I write 4 into 6, okay, so that will be, I think, root over 6, right? Just see if this is wrong or right. I mean, mix सही है गलत है. Just check that once. इसको गलती तो नहीं की ना. 6 alpha square plus minus 36 alpha की power 4 omega की power 4 minus 3 minus 2 into 2, that is 4, and this will be 12, right? 4 AC होता है ना. So not 24, it will be 12 here, right? So if it is 12 here, then this will be 4 into 3, and I'll write 3. Okay, so this is like how it is. And so you will have two roots in this case. One root will correspond to, let's say this is your, I should write it as, what should I write it as? I'll write it as plus minus omega root over, I'll write it as 3 plus root over 3 divided by 2 omega. Okay, and let us write it as some let's say alpha 1. Okay, and let us write this as alpha 2. Okay, this is your alpha 2. So you have these alpha 1s and alpha 2s, and on the very first day I taught you that the solutions can be written as the linear combination of all these like trial solutions. So one would be a, one की जगह लिख देते हैं, let's say so I wrote it as a1, and then I wrote it as e की power. अच्छा, then we have to also find correspondingly what will be the solution with respect to alpha 1 and alpha 2, like what are the eigenvectors, so that we have to find. Okay, so let us find that also at first. So let me do that also. So if I replace my alpha as plus minus alpha 1, that is this case, what I will get? So replace this here. Also लंबा है question, but you cannot help it. जो है. So here you'll get a1, here you'll get a2 equal to 0. ये था, देखो ध्यान से. Okay, and instead of minus alpha square, I will write this. The first one. The first one would give me. Okay, so the first one is, so if I replace this alpha as plus minus alpha 1. So instead of alpha 1, I have to write alpha square will be equals to alpha 1 ka square. So I'll get alpha 1 ka square here minus plus 2 omega square, and here I'll get minus omega square, and here I'll get minus omega square again, and then here I will get minus 2 alpha square plus 2 omega square. Okay, and if I replace this alpha 1 square, what I will get? What I will get. So alpha 1 square corresponding to alpha 1 square is 3 plus 1, right? So I will get simply minus 3 plus root over 3 divided by 2, right? And then I have plus 2, and this entire thing as omega square. So there's some mistake that I'm doing, and I'm not getting what is that mistake. Okay, this is it. थोड़ा सा लंबा हो गया question, but you cannot help it. Okay, just try to find what this will be like. Minus 2, and then instead of alpha square, if I replace alpha 1 ka square, what I will get? I'll get 3 plus. Is that clear? Is that not clear? ये चीज समझ में आ रही है, ऊपर से जा रही है?
Yes, sir.
ठीक है, try to find what will be the relation between a1 and a2. So this will be like a 4 and 4, and this will be like minus 3 will be 1. So this is 1 minus 2, if I'm not wrong. 4 minus 3, ठीक है. And this will be omega square here, minus omega square here as well, and this 2 gets cancelled. So minus 3 plus 2 will give you 1 minus, नहीं, minus 1 ही देगा ना ये भी. There is some mistake that I'm doing. I don't know what is that mistake. Please kindly see that. I try to solve this. Um, so if I'm replacing alpha 1 का square, चलो देखते हैं वापस, कुछ तो गलत किया, पता नहीं चला. So alpha 1 का square क्या होगा? Let us see. So alpha 1 का square. So I'm writing it here. Alpha 1 का square would be simply 3 plus root 3 upon 2 omega square, right? This is what alpha square would be. Okay, and then this, so like, so this will be uh, minus 3 minus 3 upon 2 plus 2, and then you have this omega square. So this will be 4 minus 3. This is 1 minus root 3, right? ये तो सही है. ठीक है, this will be 1 minus root 3 for sure. What about this?
सर सही है सर.
ठीक है, so this will be minus 2, है ना? ये सही है ना? 2 से 2 कैंसिल होगा, माइनस आएगा, and then minus 3 plus 2 would be, ठीक है, जो आ रहा फिर ठीक है. This will again be some omega square written here, and again there will be omega square written here, and this will be like a1 a2 would be equal to 0. Okay, so instead of alpha square, I have written alpha 1 ka square, and what is the relation that I'm getting between a1 and a2 is that 1
माइनस रूट थ्री
a
बाई टू.
a1, and then I think this will be again uh, a2 equal to 0. Is that clear? And again, if I see, this will be like a1, and then again I will have 1 plus root 3 a2 equals to 0. I think it is clear.
सर ऊपर वाले में फर्स्ट टर्म जो मैट्रिक्स में 1 माइनस रूट थ्री, उसमें डिवाइड बाई 2 भी आएगा ना.
Hmm. Okay, so divide by 2 here, right? Okay, so we'll have to solve both of them, right? Okay, so here we can see that your the relation between a1 and a2 is that a1 is equal to I can say you can take, I mean, you can take a2 as, let's say, what I should take, a2 equal to -1, and you can normalize this also, but we want to really find the solutions. Okay, so I'll write the proportionality. So if I take a2 as -1, your a1 would be equal to what? 1 plus root 3. Okay, and here also, if you take your a2 as -1, your a1 would then become 2 upon 1 minus root 3. And if you solve it, uh, if I replace, if I multiply both of these, there is some
सर
discrepancy.
माइनस टू.
I mean, I
सर
don't.
माइनस टू.
हाँ जी बेटा.
सर ए टू को अगर -1 लेंगे तो फर्स्ट इक्वेशन से A1
-2.
-2 है.
Okay, so this will be like 1 plus root 3 only, because if you multiply 1 plus root 3 above and below, you will get -2 only in below. So in any case, if your alpha square is your alpha 1 ka square, and I'm just taking it -1 because see, here you cannot solve it because you have two variables, so you have to take one. So this is how you do in eigenvectors. So corresponding to this, what are your a1s and a2? I can write that if I take as a1 as -1, so I'll write if, so this is what I'll write that corresponding to alpha square equal to alpha 1 ka square, your normal mode you can say, or you can say yeah, normal mode you can say. So what you're getting, that relation between a1 and a2 would be this. So alpha normal would be proportional to 1 plus root 3 minus 1. Is that clear? I'm barring this constant. Okay, so I'm not using that constant. Is that clear or not clear? And similarly, if you replace your alpha square as alpha 2 ka square, okay, so if I replace alpha square as alpha 2 ka square, what I'll get, just give me a minute, थोड़ा सा calculation part, it is lengthy. चलो ठीक है, देखते हैं. So this will be like minus alpha 2 square पर ढंग से लिख लेते हैं, else once there will be a mistake, then we'll not be able to rectify it. This is a ऐसा ही टॉपिक है, this इसमें यही प्रॉब्लम है. Even if you do the Lagrangian part now, I mean, this determinant is going to get repeated. There would be a different logic to it, but anyway, uh, this will get repeated. This is for sure. So you have to do this. जल्दी जल्दी से बता करो, what will be the a1 and a2? So alpha 2 was, I think, 3 minus root 3. So I'll write alpha 2 ka square would be 3 minus root 3 upon 2 omega square. So I'll replace it here. It will be minus 3 plus root 3 plus 4 upon 2. And I will write omega square here. And I'll write minus omega square here. And then minus omega square here as well. And then minus 2. So this will be minus 3 plus root 3, and then again I will write plus 2, and then I will write omega square, and then I will write a1 and a2 equal to 0. And indeed this would give me what? This would give me 4 minus 3 is 1, so this would be 1 plus root 3 upon 2, and I will get omega square from here and minus omega square here, like a1 here, and forget about this omega square a1, and this will be like minus a2 equal to 0, and another one will be minus a1, and then you can take plus minus, sorry, root 3 minus 1 a2 equal to 0, or in other words, if I write my a1 as 1, okay, और चलो यहाँ a2 को 1 लिया था ना, if I write a2 as 1, if I write a2 as 1, your a1 would be simply root 3 minus 1, right? So if this is the, if this is your solution, alpha square equal to alpha 2 square, alpha 2 ka square, the what is, how the normal mode will be proportional to, the normal mode will be proportional to, you can say, I'll write root 3 minus 1 here, and minus 1 की जगह यहाँ पे बनना चाहिए, right? Done. So the solutions would be, the solutions to x1 x2 is nothing but it is equals to some what I can write a1 e की power iota alpha 1t, and then plus a1 e की power minus iota alpha 1t. If you see, there are two roots to it, alpha 1, you can see that alpha, instead of alpha you have plus minus alpha 1, and instead of alpha you also have plus minus alpha 2. So accordingly I'll write all these things, okay, a2 e की power iota alpha 2t, and then again I'll write a2 e की power minus iota alpha 2t. And that day I told that x1 and x2 are displacements, so they represent real quantities. So what I'll do, I will simply and then like what, so what it would be, okay, so a1, इसको ऐसे लिखना था ना, एक मिनट में यार, कुछ तो गलती कर, हम जल्दीबाजी में पता नहीं चल रही है। So x1, okay, here it was, right? So a x1 हमने लिया था a1, sorry, a1 a2 ऐसे लिखना पड़ेगा, right? So I'll write it in matrix form only, no? So I'll write it in matrix form only, so the things will be easy. Things will be easy for us to do. Okay, so I'll write it in matrix form. So here it will be a1 a2, and here it will be e की power iota alpha t. Okay, is that clear? So if I replace instead of alpha 1, the first one would be, I know that the first one, if I replace alpha 1, so you have, this was root 3 plus 1, and this was minus 1, and here I can write, yeah, some constant is there, forget about it, iota alpha t, right? Alpha 1t. Is that clear? Then again, another root will be root 3 this will be the same, because see, for alpha 1 ka square, these even in a2 relations are same, that is a1 was 1 plus root 3 and a2 was minus 1 for alpha 1 ka square. So whether you take alpha 1 or whether you take minus alpha 1, this will remain uh, the a1 and a2, this column vector a1 a2. I mean, is that clear? मैं समझा पा रहा हूँ, नहीं समझा पा रहा हूँ? ठीक है? And similarly you can
Yes.
write क्या था यहाँ पे, I think root 3 minus 1, हाँ, ठीक है, root 3 minus 1 and 1 here, and here you have e की power iota alpha 2t, and then you have this root 3, and you take some constants also, so that say take some b1 or b2s. Okay, b2 b3 b4, ठीक है, and this will be root 3 minus 1 1, and there will be some e की power minus iota alpha 2t. Is that clear? And I told you in the very first day that these x1 and x2 are real displacements, so they need to be real. So हमने क्या किया था, what technique we applied, that we replaced b1 as some b e की power iota 5, and we replaced b2 as simply some b e की power minus iota 5. So if we do that, you take alpha 1 के corresponding 1 1 कह देते हैं इसको, ठीक है? If you do that, what you will get, you'll and if you see the previous lecture also, I just compactified it in form of root 3 plus 1, and then you have this minus 1, and then you have e ki power iota alpha 1 plus phi 1, and here we'll get e ki power minus iota phi 1 alpha 1 plus t. Like instead of b2, if you replace b e ki power minus iota phi 1, and if you add those terms up, what lastly you will get, I'll write that, you'll get some cos term. And similarly, the same kind of things if I do here also, and let's say if I replace b3 as c e ki power iota phi 2 and b4 as c e ki power minus iota phi 2, then what I'll get? I will simply get c, and here I'll get, I think it will be root 3 minus 1, and this will be 1 here, and here I'll get cos alpha 2, and then there will be some phi 2. Is that clear or not? Okay, so there are two independent modes. One mode, if b becomes 0, then this will be operating, and this will be operating with the characteristic frequency corresponding to alpha 2. And if c is 0, then this mode will be operating. Is that clear or not?
Sir, why you have taken this B1 as B e to power iota phi 1?
Okay.
What is
What is the purpose? Right. So in previous lecture, what I was doing is, since x1 and x2 are real, right? These are real displacements. So what technique I'm going to
yes,
do? See, I'll write b1 as simply b e ki power minus iota phi 1. Okay. So this is a technique to compactify it in terms of real solution. So what I'll do, I'll write it this way. I'm just showing in these two things. Okay. The first two, I'm like this. This is what I'm showing it here. So it will be e ki power iota alpha 1 t and then plus iota phi. Is that clear? And then second term, if I take the complex conjugate of it, so what will happen? If I don't take, then there will be some imaginary term associated, in which cannot be case. So this is sort of guesswork, you can say. And so here I will have root 3 plus 1 and minus 1 here. And then I will have e ki power minus iota alpha t and minus iota phi 1. And there should be t here as well. There should be t here as well. Okay. So what I'll do, I'll take this b here and root 3 plus 1 minus 1, and what it will be like, e ki power iota theta plus e ki power minus iota theta. This will be 2 cos of alpha 1 t plus phi 1 t. phi 1 नहीं होना चाहिए ना, ये phi t नहीं होना चाहिए, सॉरी नहीं, यहाँ पे t थोड़ी था, ठीक है. So this will be like phi 1. So what it will yield you, it will yield you a real answer. Had I not taken this b as complex conjugate of it, then the solution will get stuck in real imaginary part. There will be a solution in imaginary part also, and so x1 and x2 cannot be quantified rightly, because x1 and x2 are real displacement, so to say. So this is a technique by which you can write things in a real form. Is that clear? And after all, b1 and b2 are arbitrary constants. So they are arbitrary constants. You can take all sort of things. That is absolutely fine. So if I take b1 as b e ki power iota phi 1 and b2 as b e ki power minus iota phi 1, then things will be fine. This is similar to what we do in your standard 12th. So for example, if a cos theta and b sin theta are written, what do? You say that since a and b are real numbers, why not take a as some arbitrary constant, let's say cos alpha, and by dividing it by root over a square plus b square, certainly you do this now. ये छोटे बच्चे थे तो ये करते थे कि नहीं करते थे. And
yes, sir, yes, sir.
this is something that lies between minus 1 and 1. This is something that lies between minus and 1. So your sin alpha and cos alpha can be appropriate substitutions to do the same. What it will do in return, it will compactify our solution. This is what is the strategy here as well. And we need a real solution. So if I don't use a complex conjugate here, then there will be some part which will remain in complex, and you cannot quantify your displacement in terms of your complex number, complex argument. Is that clear?
Yes, sir. Sir, initially, we took x1 and x2 as a well, trial solution,
Right.
imaginary solution only, no?
हाँ,
तो वहां पे हम आयोटा हटा के नहीं कर सकते सर
आयोटा
सॉल्यूशन.
अटैक कर सकते हैं, but see, understand my point. Whenever you are doing oscillations, right? Oscillations means what? You need some periodicity. Okay, so you need some periodic solutions. So trial solution, if you assume e ki power alpha t, now you see as t tends to infinity, this will blow up. Right? You see, you cannot control. You cannot write this term in in terms of sines and cosines. Is that clear? We are doing a periodic solution, so we want somehow that our solution should be one which at least have some sort of periodicity. Okay, so we want an oscillatory solution, so the appropriate thing would be to take a
Okay,
sinusoidal function. Is that
ओके
clear?
सर. एंड सर ये जो हमने ओमेगा लिया ये हमने एज्यूम किया है कि सेम होगा.
एक मिनट में देखता हूँ. ना ना ना, सेम नहीं होगा. सो व्हाट आई हैव डन, in standard 12th also we know that your k by m we take it as omega square. This is the natural frequency of oscillation, so this is what I have taken, omega k by m. So k is a constant, m is a constant, I have equated it to natural frequency omega square. Okay,
बट सर
and I
ऐसा
think,
हो सकता.
हाँ,
यस
ऐसा
सर.
possible है if these k1 k2s are different, then there would be a problem, but here k is same. Okay, so is that clear now? ये चीज समझ में आ गई? हम इसको लैग्रेंजियन में
यस.
और ढंग से करेंगे. द ओनली पॉइंट वाज कि एमएससी पीपल वर कमिंग बिकॉज दे हैव देयर एग्जाम्स नाउ, सो दे आर नॉट कमिंग. So I thought कि why not start this? I will finish it off anyway. So next week we are going to start linear vector space, that is for sure. So वो तो नहीं छोड़ेंगे हम, but on this side we'll keep things at some basic level. Okay, is that clear till now? Now understand. Uh, what should I say? So we have arrived at solution. So our solutions are x1, x2. Again, I'll write here. It is, I think, I'll write like they are proportional to root 3 plus 1 and minus 1. This is 1. Some I'll write omega 1t plus phi 1. That's not omega 1 here. You get the alpha 1 phi. And then another solution would be root 3. I think it was. एक मिनट से देख ही लेंगे यार, गलती ना हो जाए. Root 3 minus 1,
3
and then
plus
you have
3 by
1
2,
here,
3 minus 2.
and here you have cos alpha 2t plus phi. Okay, is that clear? So these two are the solutions. Okay, now, okay, so this is mode number 1. This is your mode number 1. In previous class we had these modes as anti-symmetric and symmetric modes. Here also these are anti-symmetric and symmetric modes only. See, but only differences with regards to the amplitude. So these are two independent modes of oscillations which are executing oscillations with frequency corresponding to alpha 2 and frequency corresponding to alpha 1. So what is alpha 1? You know, in terms of your omega, you have alpha 1. You know that what is your alpha 1? You know that your alpha 1 ka square is 3 minus root 3 ka omega square. And another frequency is, so what are you getting? So these coupled oscillators, if you take individually these two things, so this is executing oscillation with a pure frequency, with a pure frequency corresponding to alpha 1. So corresponding to alpha 1, this particular is an independent oscillations, and this particular also represent an independent oscillation. However, x1 will be some linear combination of both of them, and x2 will be linear combination of both of them. Is that clear? So these independent motions that go along is called as your normal mode. So this is what we did in the previous class also. When your masses were equal, then you did not have this term root 3 minus 1. Rather, you had two different oscillations. So one oscillation was the symmetric one, where your x1 was equal to x2, and another one was x1 equal to minus x2. So in the first case, both of them were oscillating in the same direction, and in the second case, both of them are oscillating opposite to each other. And we saw that for the second case, the frequency obtained was greater than the frequency obtained for the first case. Because for the first case, it is equal to the free oscillation only. There's no role of the spring. But if they oscillate opposite, then this particular force will start getting executed, and this particular force will start come into play and will actually alter the restoring forces on both of these masses. So these are called as independent modes. So these are called as normal modes in theory of oscillations. Normal, you can say frequencies called like eigenvector wise. If I say, so these are called as eigenvector normal coordinates. So if I want to represent relation between x1 and x2, I'll say these are the normal coordinates. These are called as normal coordinates. ये समझो नॉर्मल कोऑर्डिनेट का मतलब क्या है। नॉर्मल कोऑर्डिनेट्स मतलब वो कोऑर्डिनेट्स which oscillate with a pure frequency. With a pure frequency मतलब single frequency. So जैसे for example, this particular the first term here you can see it is oscillating with the frequency corresponding to alpha 1. So this is one of the mode. This is one of the mode of oscillation, and this is another mode of oscillation. These are called as normal modes. And if I want to find the relation between x1 and x2, that relation between x1 and x2 and in totality is called as your normal coordinate. Is that clear or not clear, or should I repeat it again? So जैसे कि let us take for simplicity is constant को नहीं assume करते. Let us take for simplicity b1 as some 1 or b2 as some like इसको एक बार को भूल जाते हैं. Let us not get into that. So I'll write x1 is equal to simply root 3 plus 1, and I will write cos alpha 1 t plus phi 1, and I will write plus root 3 minus 1 यही था ना शायद, और cos गलत तो नहीं कर दिया ना, अच्छा हो जाएगा गलत होते ही. So I think if I'm not wrong, this was I think alpha 2 plus phi 2, ठीक है. And the second one was, अगर हम देखें तो ये था शायद root 3 minus 1, and then I had cos alpha 1 t plus phi 1, and then I had this will be 1 I think, 1, and this will be 1 minus 1. So this will be शायद minus 1, पहला वाला minus 1 था, दूसरा 1 था 1, and this will be cos alpha 2 t phi 2. Is that clear? So if this is the case, how to find the what I would do is I would multiply this by root 3 plus 1. So I will multiply this by root 3 plus 1. So if I multiply this by root 3 plus 1, what I will get, I will simply get that x1 plus root 3 plus 1 x1 is equals to, it will be like root 3 minus 1 cos alpha 2 t plus phi 2, and there would be some plus root 3 plus 1 cos alpha 2 t plus phi 2. I've ignored constants, forget about it. Only point that I feel is that this will be some constant. I'm not bothered about it. This will be cos alpha 2 t plus phi 2. Okay. So one of the normal modes I told you corresponds to alpha 2. So with respect to alpha 2, I'm seeing that x1 plus root 3 plus, yeah, x2 root 3 plus 1 x2. This particular linear combination of x1 and x2, this particular linear combination of x1 and x2 are executing oscillations with frequency corresponding to alpha 2. So this is one pure frequency. And this particular one pure frequency is called as one of the normal modes. So, and what this is called on the left hand side, this is the normal coordinate corresponding to this normal mode. Is that clear or not? Is समझ में आया
Yes, sir.
process like it? And another normal coordinate, if you want to find another normal coordinate, if you want to find, what you need to do is simply
Root 3
multiply
minus 1.
3 minus 1. So this particular mode will be absent there, and this particular mode will start getting executed. All these things can be found if I am supplied with some initial conditions. So if I am supplied with some initial conditions, then I can find what is alpha 1, what is alpha 2, like all these things we can do. Okay, so another normal mode will be x1 plus root 3 minus 1 x2. So, and this will be another normal coordinate. This will be another normal coordinate which will be executing frequency, which will be executing oscillation with another pure frequency. So these two terms one needs to remember that these individual frequencies, or you can say individual oscillations, you can say, are called as your normal mode of oscillation, and correspondingly these two terms are called as your normal coordinates. So these are the normal coordinates corresponding to two different normal modes of possible oscillations. Is that clear or not? So this was the case of unequal masses and three springs. In the next class, we'll be doing some same question, but we'll change this this spring constant. the spring constant, which is coupling the both of these masses. Is that clear?
Yes, sir.
Okay, thank you so much. Okay, so we'll join in the next class.